Hi, I'm Emily Banks, and this is my Sportsman 3 Unit 6 unit project on penicillin for my research journal. Going over what penicillin is, it is a beta-lactam antibiotic drug that is used globally to treat infection. Beta-lactam are basically antibiotics, which are medicines that are used to fight bacterial infections, but they contain a beta-lactam ring which is able to disrupt bacterial cell walls and cell wall formation via covalent binding to the penicillin binding proteins. Expanding more on how beta-lactam and penicillin works, it is able to kill bacteria by using its beta-lactam ring to bind to the DD transpeptidase, which is what makes up cell walls, and then after binding with it, it is able to inhibit the cross-linking activity and overall preventing new cell wall formation. Without a cell, bacterial cells are vulnerable to outside water and molecule pressure, meaning that they die off almost instantly. Human cells, though, don't contain a cell wall, only membranes, so penicillin isn't able to affect human cells, which is why it's safe for humans to use in the first place. Here's a cool video I was able to find of how penicillin works and how we are able to see it using microscopes and things, of course. This is E. coli, and as you can see, after the penicillin is used, the E. coli slowly expands and expands because the cell wall was broken, and it eventually completely bursts and disappears entirely, which you can see start to happen now. Overall, this is just a super cool example I found that really shows and demonstrates how fast penicillin works and how effective it is. One of the most interesting things about penicillin, however, is its history and how it was founded. It was in 1928 when Dr. Fleming actually came home from a vacation and found his petri dish of Staphylococcus aureus, which is basically a bacteria that causes irritation and other diseases and bacterial issues in humans, and to be contaminated by mold. This mold, though, was actually found to be preventing the normal growth of the germ, however, which Fleming then did further research in. Despite Dr. Fleming being the one to find penicillin, it was through the work of Dr. Howard Florey, Dr. Ernest Chain, and Dr. Norman Heatley that penicillin was revolutionized by turning it from its mold form into a purified and sustainable, easy-to-use product that was then being produced by 65 billion units a month by the year 1942. This was huge for the time because World War II was going on, and a majority of deaths were being caused by bacterial infection. Penicillin is a part of nature that humans were able to utilize in a way that were able to save over 2 million lives. But because of antimicrobial resistance, a varying number of antibiotics, including penicillin, haven't been able to treat as much as they used to be able to in the past. Fleming himself had warned against antimicrobial resistance, saying that it's not difficult to make microbes resistant to penicillin in the laboratory. He basically said that by exposing bacteria to small concentrations that don't immediately kill them, the bacteria will learn to resist penicillin, and then leaving penicillin overall insufficient in being able to kill the bacteria. Even with Fleming's warning, penicillin is now nearly ineffective against all strains of Staphylococcus aureus and Neisseria gonorrhea, which is kind of ironic because it was the Staphylococcus aureus that Fleming had been studying on his petri dish when the penicillin mold had killed off the Staphylococcus. In an effort to prevent antimicrobial resistance, the World Health Organization has adopted the Global Action Plan on Antimicrobial Resistance. This includes 5 steps in order to help prevent more antibacterial medications being put out of use because of antimicrobial resistance. These steps include improving awareness and understanding of antimicrobial resistance, strengthening knowledge and the amount of data on antimicrobial resistance, reducing the incidence of infections through effective hygiene measures, optimizing the use of antimicrobial drugs in human and animal health, and increasing investment in new drugs, diagnostic tools, vaccines, and other interventions. Despite this effort, though, scientists have recently found themselves in a discovery void, meaning meaning that in recent years, antibacterial medications have been found less and less, and therefore the ones that we have been using are becoming less effective without new alternatives. That is the end of my research project on penicillin. Thanks for watching.